This is a second example of solving an exponential equation that has two exponential terms on different sides of the equation. So we want to solve for x, and we're given 11 to the negative x plus 5 equals 4 to the negative 3x. So let me grab my pen tool here. And I'm going to start by taking log or natural log of both sides. So I'm going to go ahead and do log of 11 to the negative x plus 5 equals log of 4 to the negative 3x. All right, now what I want to do is use the power property of logarithms to bring the exponents down in front. And because I have negative x plus 5, I have that plus in there, I have to make sure I put parentheses around my exponent. So negative x plus 5 needs to have parentheses around it, so I know that the whole thing is multiplied by log of 11. And this is equal to negative 3x log of 4. I don't need to have parentheses around the negative 3x because there's no adding or subtracting on it. So now log of 11 is just a constant. So I want to distribute log of 11 into that set of parentheses. So I'll end up with negative x log 11 plus 5 log 11 equals negative 3x log of 4. All right, so now I want to have all of my variable terms on the same side of the equation. So I'm going to go ahead and add x log 11 to both sides. So over here, x log 11 minus x log 11, those will cancel each other out. And so on the right side, the left side of the equation, I end up with 5 log 11. And on the right side, I end up with x log 11 minus 3x log 4. So I don't try to change them into a single log. I'm just going to go ahead and factor out the x. So I factor x. And so I end up with 5 log 11 equals x parentheses log 11 minus 3 log 4. And now I'm going to divide both sides by log 11 minus 3 log 4. So I divide by log 11 minus 3 log 4. And on the left side, I do the same thing. Divide by log 11 minus 3 log of 4. And over here on the right-hand side, those expressions cancel and I'm just left with the x. And so my answer would be x equals 5 log 11 divided by log 11 minus 3 log 4. So that's what I want to put in my calculator. Notice that they are asking for a decimal answer rounded to the nearest thousandth. And so I'll go ahead and pull up my calculator here. And I want to put in that expression. So I'm going to type in 5, go to function to get to your log 11. close the parentheses around the 11, and then divide by log 11 close the parentheses around the argument, around the thing being plugged in, minus 3 log 4. All right, so we've got our answer here. We've got negative 6.808. And if you wanted to check that answer before entering it, like if you were in a test situation, what you would do is you would look at your original function. Let me get rid of some of this so I can actually move the calculator over. Okay, so you look at your original equation, 11 to the negative x plus 5. I'm going to go ahead and put 11 to the power of parentheses. Negative x would be a negative 6 would be a positive 6.808381235 plus 5. I'm getting the plus 5 from the exponent in my original. Okay, and now I want to do the right side of the equation. So 4 to the negative 3x. So I'm going to do 4 to the power parentheses negative 3 times x. So times negative 6.808381235. And I'm just checking to make sure that I get the same result on the left side of my equal sign and the right side of my equal sign. So 11 to the negative x plus 5 is equal to 4 to the negative 3x. So I know that I got the right answer, and I would just go ahead and type in negative 6.808 as my answer.